In GraphQL, we have this concept of a scalar. And a scalar in GraphQL is basically a leaf node of a query. And a leaf node is a field that cannot be queried further via subfield selections. And what I mean by that is, if we come here to my query, ID, first name and last name are leaf nodes, which are therefore scalars, because I cannot query them any further. Currency is also one, client is not. Now, if you don't know what a leaf node is in tree data structure, it's simply the last node on each path. So 2, 10, 5, 11, 4. So the ones you can see hanging at the bottom. Now, if we go back to our GraphQL Java here, the GraphQL specification actually specifies that 5 default scalars must be present in the type system. And if we come into GraphQL Java and we come into our create bank account input, if I create a new field, you can see that them 5 are present, plus the currency which we created earlier. But this isn't enough, because in GraphQL we want to customize this so we can add certain checks or specify more detailed types or more detailed scalars to our end users. And one way we can actually increase these is by using an additional library, and this library is GraphQL-java-extended-scalars. So in this tutorial I'm going to be integrating this and showing you an example, and we'll pick it now. But whenever you bring this in, you'll have access to DateTime scalars, which are extremely important. So you have now a DateTime, a time and a date. There's an object scalar, a whole range of numeric scalars, which are really, really useful for input validation as well. Regex scalars, and some others. So let's go ahead and dig in and actually come and use this. So the first thing we want to do is actually bring this dependency down into our project. So let's go to the POM and let's bring in the extended scalars. I'm excluding GraphQL Java because I always want this GraphQL Spring Boot starter to define the GraphQL Java version and override everything. So here we don't want to have a custom scalar version overriding our main dependency. So now once that's on the class path, the first step is to really get the schema right. And here we need to define the scalar type. But how do we know what the scalar types are? Well, in order to see them, we can open up the extended-scalars.java. And here you will see a Java implementation of all of the custom scalars. Now, the schema name you have must be the name, the first parameter passed into the PositiveInt Scalar super overridden constructor method. Now, luckily for us, this name also matches the name of the field here inside this extended scalars. So all we need to do is come down and we pick the scalar we want to use. So in this case, it's NonNegativeInt. We want a NonNegativeInt for our age, and we just paste it here. That's it. So now we have access to the scalar, and inside the create bank account input, if we specify age, now we have access to a NonNegativeInt. That's all you need to do for the schema side. Now for the Java side, of course, we need to introduce an int age. And of course, it's not a non-negative-int, it's a simple int. This is just going to perform the validation on the way in to ensure it's the correct serialized type. And what we want to do then is actually tell the system that we want to use the non-negative-int scalar. So in order to do that, we need to create a bean of this type. So let's go ahead and create a class called Scalar config and make this a configuration bean. And inside here, we'll return a GraphQLScalarType of NonNegativeInt. And inside here, let's say extended scalars dot NonNegativeInt. And that's it. That's all we need to do. So go ahead and let's run the application. And these scalars, the custom scalars, can be used for input as well as response, so like output types. So you can use them both ways. If we go to our playground, so here, of course it failed because it's -1. If I say -2, it'll fail. -100, it'll fail. But 0 will pass. 1 will pass, and etc. So here, this is how you can use the custom scalars. And how do they actually work? Where does this message come from? Validation input.age is not valid non-negative-int. Well, when you define a custom scalar type, this actually extends the GraphQLScalarType. Here you provide the name and the validation description. But the key point here is this coercing class or interface. And this is the interface will actually be used to parse and serialize the object values. So here, because it's basically on an integer, we override and use the existing int coercing one, and we override the check method. If I is greater than or equal to 0, we return I and continues fine. Otherwise, we throw the exception. So you can go ahead and look at all of these scalars, and you can look through them to see how they're implemented and if they suit you. And if you want to implement your own, you can simply extend the GraphQLScalarType and implement the coercing interface, and that should be you. And I'll show you that in another video. So I hope you guys enjoyed this tutorial, and I will see you in the next episode where I look into the date custom scalar types. Bye.